Quadratic equations play a significant role in the projection and trajectory calculations of rockets launched into space. Here's how quadratic equations are applied in this context. Rocket trajectory. The motion of a rocket can be described using the laws of motion and calculus. When a rocket is launched, it experiences both vertical and horizontal motion. The vertical motion is affected by the force of gravity, while the horizontal motion is influenced by the rocket's propulsion. The trajectory of the rocket can be determined by solving a system of differential equations, which often leads to quadratic equations. These equations help calculate the rocket's position, velocity, and acceleration at any given time. 2. Launch angle and range. The launch angle of a rocket, which determines the angle at which it is launched into space, affects its range or distance covered. To achieve the desired range, engineers and scientists need to find the optimal launch angle. This optimization problem involves maximizing the range, and quadratic equations can be utilized to solve it. The range equation typically takes the form of a quadratic equation with the launch angle as a variable, and the maximum range is determined by finding the vertex of the quadratic function. Height. Determining the maximum height attained by a rocket during its trajectory is another application of quadratic equations. The rocket's vertical motion is influenced by the force of gravity, which causes it to rise and then descend. The height attained by the rocket can be determined by finding the vertex of the quadratic equation that represents the rocket's vertical motion. The maximum height is achieved when the vertical velocity of the rocket becomes 0. 4. Time of flight. The time it takes for a rocket to reach its target or complete its trajectory is known as the time of flight. Quadratic equations come into play when calculating the time of flight. By solving the quadratic equation that represents the rocket's vertical motion, one can determine the time it takes for the rocket to reach a specific height or complete its trajectory. 5. Landing calculations. When planning the landing of a rocket or a spacecraft, quadratic equations can be used to determine various parameters. For instance, engineers need to calculate the time and location of the landing site, taking into account factors like atmospheric conditions, thrust, and gravitational forces. Quadratic equations can be employed to solve these calculations, incorporating variables such as time, velocity, acceleration, and position. By utilizing quadratic equations, scientists and engineers can accurately model and predict the trajectory, range, maximum height, time of flight, and landing calculations involved in launching rockets into space. These calculations are crucial for the successful planning and execution of space missions.